Bismillahirrahmanirrahim. Assalamu alaikum, dear students of 9C. This is your chemistry class, lecture number 2, and this lecture is from your chapter number 5 according to your book, and the topic number 3 according to CIE syllabus, and the topic is formula, stoichiometry, and the mole concept. Dear students, the objectives for this lecture 2 is to understand the way how to calculate the empirical formula. Number 2, to calculate the stoichiometric reacting masses with the help of Avogadro's law. So in this case we will consider as well the Avogadro's law, what is Avogadro's law, or how we can calculate the reacting masses, inshallah. The third point is the concept of solution concentration to process the volumetric experiments, and the fourth and very important, to calculate percentage yield and percentage purity of the substances or reactions. So we are going to focus firstly on the stoichiometric, but before going to that I would like to say you, whenever you are going to start your chemistry lesson, please have the periodic table of elements with you. This periodic table will gives you the information about the elements, which is very important for the chemistry classes, specifically when we are learning the stoichiometric or the mole concept. So leading towards the stoichiometry is the relationship between the relative quantities of substances in a reaction of forming a compound. What does it mean? It means that whenever a reaction is proceeding, what are the quantities of the reactants are used and what are the products are being made, and there must be a relationship, very strong relationship on both sides of the reaction. If it is not so, then this is not possible to carry out the reaction. How it is important, we are going to consider stepwise. So first of all, I am going to have your attention about this, the mole concept. What is mole? The mole of a substance, when we want to have, for example, the 1 mole of a substance we want to have, so we have to have its relative atomic mass or relative molecular mass or relative formula mass. What is relative atomic mass and what is relative molecular mass and or relative formula mass? How we can have it? For example, this is sodium. The sodium is having atomic number 11 and the atomic mass is 23. Actually the average atomic mass is 22.99, so we are going to take it as 23. When we take the 23 atomic mass of sodium and expressed in grams, so 23 grams of sodium, if we take 23 grams of sodium, this is 1 mole of sodium. In this how we can have the mole of the elements or atoms by having their atomic masses. So periodic table will help you to get this. So sodium is having 23 atomic mass. If we expressed this 23 atomic mass in grams, we will be able to get 1 mole of sodium, like with all the atoms. And if we want to have the molar mass of the compounds, for example, over here I discuss to you the example of calcium chloride. The atomic mass of calcium is 40.08 grams, while the atomic mass of chlorine is 35.45 grams. This is the atomic mass. If we express these grams masses into grams, then we will be able to get the 1 mole of each, calcium and chlorine. But here we are going to discuss the calcium chloride. Calcium chloride is having 1 atom of calcium and 2 atoms of chlorine. So we have to put the atomic mass of calcium and twice the atomic mass of chlorine. Then we will be able to get the atomic molecular mass of the calcium chloride, which is about 110.98. If we convert this 110.98 molecular mass of calcium chloride and expressed in grams, then we will be able to get 1 mole of calcium chloride. 1 mole of calcium chloride, and this is how we will be able to get the molecular mass of all the compounds. We have to get the individual atoms present in the compounds, the atomic masses, and then we have to sum up these according to the formula, and then we express the molecular mass in grams, and that will be equal to mole, 1 mole of that particular compound. So this is how, dear students, you have learned that how the atomic masses or molecular masses can help us to get the moles of that particular atom or compound. Now we are moving towards 3 different ways to get the moles. These are very important regarding to your um, stoichiometry of different chemical reactions. Sometimes you are giving the mass, sometimes you are giving the particles, sometimes you are given with the volume. So if you are if you are given with the particles, so divide these particles by this 6.022 into 10 raised to power 23. This is Avogadro's law. Avogadro's law is this, that 1 mole of every substance has this particular number of particles, 6.022 into 10 raised to power 23. If you are giving some particles, atoms, ions or molecules numbers, divide this number by 6.022 into 10 raised to power 23, then you will be able to get the moles, the number of moles. Another way, the mass is given, you have to divide the given mass of the atom or compound by the molar mass of that particular atom or compound, then you will be able to get the moles. And the third way is the volume. If the volume of the gases is given to you, divide it simply with the 22.4 and you will be able to get the number of moles of that particular gas. So in these 3 ways, these are the 3 ways which will help you to get the moles, and if the moles are given, then you have to multiply with these Avogadro's number, you will get the particles, and you multiply the moles with the molar mass, you will get the mass. And if you are going to multiply the moles with the 22.4, you will get the volume of that particular gas. So these are the different ways to get the moles: particles, mass or volume. Dear students, now we are going to focus on the reacting masses and the volumes. Timely yet. What is this nonsense?